a new project. We're gonna do a 2D game. Make sure you name it so you're organized. We'll just name it Video Hacks Demo, and I'm gonna create project. This might take a while depending on what computer or laptop you're using. Unity is a slightly taxing program. If you have like an i5 or better, you should be able to run it just fine without it crashing constantly. But it might take a while to load, and that's just something you're gonna have to deal with it. So while it's loading, I suppose I'll give a kind of rundown of what Unity is. Unity uses the C# scripting language if you want to code in Unity, but there's a lot of stuff you can do in Unity without code. It is it's a game engine, much like if you've heard of Unreal Engine, but it's very similar to Unreal Engine, but much easier to use, and it's a lot more advanced than like Game Maker or Godot if you use any of those. Um, Unity has a physics system completely built into it, which is one of the greatest parts of Unity. You don't really have to deal with any of that. And in addition, I'd say that it has a pretty good UI. It's once you've got it down, once you've had a little bit of practice, I think you guys will agree that the UI is very manageable, easy to work around. But at first, when you open up Unity, it may seem like a lot. That's fine. For all of you people who are just now joining, I am creating a new Unity project in 2D. And it's just loading now. Yeah. And for those of you who are following along, if you just put in the chat when your Unity has completed loading. It's taking a while to load, but pretty much today, if everything goes to plan, this really should only take like an hour to an hour and a half, I think. And hopefully we'll have created a very simple 2D like platformer game that would be really easy to build upon when if you guys feel like it after this is over.
Wait, I'm just curious, what are we making today? Or like what game?
My hope is that we can make a very simple 2D platformer game. Think kind of like Super Mario. And then I'll teach, but mainly I want to teach you all the components of Unity. So then when you have time after this workshop is over, that you can add whatever you want to the 2D platforming game.
Okay, thanks.
While we wait for the Unity to load, could we maybe talk more about like your experiences in game dev or like previous projects you've created?
Sure. So I started game design over quarantine. It was really that I was really bored with, I had been doing a lot of programming using mostly Java. And if you are, by the way, if you do use Java, Java and C# are very similar, so it's not much of a learning curve whatsoever. Um, but yeah, so I was doing coding mostly with Java, and I was kind of getting bored with it over quarantine, and so I looked at I wanted to find something else to do, and that's when I stumbled upon a YouTube video about developing games in Unity. And so I watched the YouTube video, and then I just found a bunch of other tutorials and YouTube videos on Unity. The main two channels that I suggest to you guys are called Brackies and Blackthorn Pod. Both of them are amazing YouTubers who have a lot of Unity tutorials. And so during quarantine, I just watching these tutorials, I just got into it by myself and I really, really enjoyed it. So I just kept on going, making projects by myself um, until until last school year when I reached out to a local game design company in my area and I got an internship with them. They make arcade games, a place called Raw Thrills. So for a month or two, I kind of interned with them, see what it was like to be in an actual game development environment in the real world. And this summer, I was a part of the National High School Game Academy offered at Carnegie Mellon, which um, the Game Academy at Carnegie Mellon. We worked in teams to recreate an old arcade game. I recreated a game called Tempest, and I made my own VR game with a team of four others, which was a lot of fun. So hopefully your guys' Unity has loaded. This is the default screen that you'll see for a 2D game. You have kind of five main windows. First is on the top left here is the hierarchy. The hierarchy is all of the things in your scene. And a scene, this is called sample scene, you can kind of think of as a level in your game, or one of them could be like the main menu. It's pretty much, it's like, something a bit like that. And then these are all of the things in your scene. So these are all things, objects that you'll see in that level or in that main menu scene. Next, this is the scene view. Here it'll visualize and you'll see all of the stuff in the level. This is where we'll be working on the level. So we'll be putting the player here, we'll be putting platforms. Then if you just tab over to the game view, this is what the camera sees. So here you can see in our scene view, we have the main camera. If we press W, we can move it around, but clearly there's nothing in our scene. So we're going to reset that. And then here's our inspector. The inspector shows all of the components attached to each game object. It's called, all of the things in the hierarchy are called game objects. So every single thing are game objects, and the inspector shows all the components to the game object. So one component is the transform, which is on every single game object. This is position, rotation, scale. If we go back to the scene view, we can change the X value, which is position, change the rotation, which in a 2D game does not look right. So we're going to set that at 0 and change the scale if we so wish. But we're going to reset that. So if you click the three dots and reset it, it'll go back to 0, 0, 0, 0, 0, 0, 1, 1, 1, which is what you want for the main camera. And this, because it is the main camera, it has the camera component. and it also has an audio listener. So if you want to add sound into your game, the camera will listen for it. And finally, down here, you have your project tab. These are all of the files in your game. Here, our only file is the scene. Say we wanted to create something, like we could create a script, or we could create some another scene, a material. They will all show up in the project tab. And you can go from the project tab. You take assets, they're called, from the project tab and put them in your hierarchy so they can show up in your scene. If anyone has any questions, I know I'm going kind of fast because we only have an hour and Unity has a whole lot of features. But if you have any questions, please ask them in the chat or just speak out loud would be preferable, as I don't really look at the chat that often. And then these tabs up here, for now, we're really not going to worry about, but they all each have its own purpose. So in order to create, okay, now I'm going to go through like keybinds. So if you click W, you'll get the to move objects around. So if you click on the main camera and you click W, you'll be able to move it around X and Y. And then E will go to your rotation. So if you want to rotate it, click E and you can rotate it in the scene view. R will go to your scale tool. And those are your main ones, W, E, and R. And obviously Control S to save. Make sure you save a lot in Unity. Although I haven't had that many bad experiences with it crashing. When it does crash and you haven't saved, it can be really soul crushing. So now we're going to create a new object in the scene. We're going to create a player object. So create a 2D object, a sprite, and for now we're just going to have our player be a square. And that's our square. So we're going to rename it player. And if we click W, we can move it around. And right now it only has a sprite render, so you can see it, and the transform, of course. We're going to reset the transform so it goes back to the center. And what do we want in our player? Well, actually, first, let's play the game. In order to play the game, you click this button on the top. That's to play the game. And then the middle button is to pause the game in the middle of play states. Right now, there is absolutely nothing in the game view, but we have a square in our scene. And this is another important feature to realize in Unity, is that Unity 2D projects are really just 3D projects that are on one play. So it's kind of like fake 2D, and you can switch between that using the 2D button up here. But as you could see, the camera and our square are kind of on the same plane. So you're not able to see the square. So what I like to do to fix that is go to our camera object and on the Z go like to -10. And now when we go to a game view, we'll be able to see our square. And to move around in the 2D environment, if you have a mouse, which I highly recommend using a mouse, you can hold the middle button and drag it around, or right click, and left click is to select stop. Everybody cool on that? Right. So back to our player. So we see it in the game view, it exists, but when we play it, absolutely nothing happens. Right. So first, we're going to want to give it a box collider. So you can hit add component and just search for box collider, press enter, and you'll see if we click edit box collider, it is around our player box. A box collider is for collisions. And like I said, Unity has a built-in physics system. And if we have a player that we want it to jump onto platforms or like land on platforms and not fall through, it's going to need a collider to collide with the ground or walls that it may hit. But still, if we play it, nothing will happen. Because while it has a collider, no physics are acting on the object. In order to get physics to act on the object, you need to add a rigid body 2D, is what it's called. Oh, sorry. We're gonna delete the box collider, add a rigid body 2D, and then add a box collider. Sorry for that. So you'll need to delete the box collider. You need to add the rigid body 2D first, and then you can add a box collider. The weird thing Unity does. But now, so now that you have a rigid body 2D, that gives physics to the player. So if you see in your inspector window, you will be able to see rigid body 2D in the inspector. You have so many options. One is simulated. This means it'll simulate the physics on the object. If you turn that off, no physics, or no, take it out of the simulation, no physics will be attached to the player object. Obviously, we want that. You can adjust its mass, its drag, how gravity affects it, add constraints, a bunch of other things. And with the box collider, there are also a few options. We don't really need to worry about any of these right now. So now if we play it, we have our player, but it kind of just falls because of gravity, because of Unity's physics system. So we need a ground. So we're going to do that by creating another object, a sprite, another square. We're going to call this ground. So if you click W, again, you can go to the transform and you can move it around. We'll move it to underneath the player. If you click R, you go to the scale tool. So scale it up. We'll call it there is about fine. And also because it's a ground, we're going to want to change the color of it. So in the inspector, go to the color and the sprite renderer. If it's closed or something, just open it. And I'm going to color it green, just so we can tell the difference between the player and the ground. So now we're going to play it, but you'll find that it does not do anything because no physics has been attached to the ground. So this is kind of like tedious to work with a little bit, but you'll get used to it over time. Pretty much, you need to remember, in order for a collision to happen, you need a box collider or some sort of collider on the two objects, and you need a rigid body in at least one of the objects. The rigid body provides physics, and the collider collides with other things. So we're going to add a rigid body to the ground in the inspector, and we are going to add a box collider. Now, because we don't want our ground to fall, right? So we're going to change the gravity scale to 0 on our ground. This way, gravity won't affect it, and it won't fall or do anything. In addition, we also want to freeze the position and the rotation of the ground so it doesn't move. So open up the constraints tab in the inspector of the rigid body 2D and check in freeze position and check freeze rotation. This way, this object will not move, but it will still be simulated, so it'll stop. It'll still provide a physics collision with the player. So now, finally, where we have a player who lands on the ground, and this is a good start, but the player really doesn't do anything yet. We want, for a 2D platformer, we want our player to be able to move left and right and also even jump. So in order to do all these behaviors, Unity doesn't have just a component in the inspector that we can add in those movements. We're going to need to do that through script. So in order to stay organized, which staying organized in Unity, by the way, is very helpful because with bigger projects, you get a lot of assets. You get all your art assets, sound assets, materials, all your scripts. You really need to be organized in Unity. So I stress that a lot. In our assets file, in the project tab, we're going to create a new folder. We'll call it scripts, so we can put all of our scripts in this folder. And inside of the scripts folder, we're going to right click, create, and we're going to create a C# script. I'm going to call this player movement. So this is the player movement script, and we're going to get into scripting in Unity. The first main thing about scripting in Unity is I highly suggest that you use Visual Studio. When you downloaded Unity, you would have been given a here I can show you. When you download Unity, you would have been given a screen such as this that'll tell you modules to install with your Unity version. Definitely install Visual Studio. And then all of these are if you want to like build for iOS, if you want to build for Linux, if you want to build for Macs, or WebGL, so you can put your game on a website. You can add those if you'd like to, but definitely you need Visual Studio so you can code in Unity. You can also code with, say, Sublime Editor or Visual Studio Code, but they don't work as well with Unity, so I suggest that you use Visual Studio. So this is the default script in Unity. Like I said before, it's in C#. Here we have our using phrases. These two don't really need it, but we'll keep it there. And then obviously using Unity Engine. And you'll inherit from the mono behavior class. This is I think, library of C# files that dictate all of the Unity stuff, specifically Unity things. So if you want to create a script in Unity, usually you want to keep the inheriting from mono behavior pre-made methods. Start and update. And Unity will provide you comments that are fairly accurate. Start is called before the first frame update, and update is called one per frame in your game. So any code that you write in the start method will be called once you play the game, and any code you write in the update method will be called every single frame. So what we want to do is we want to add movement to our character. And you do this by, say, if you click the right arrow or the left arrow, it should move right and left. So because you want it to move right or left every frame and not just only at the first frame, you're going to put this in the update method. And what we're going to do is we need a way to get, actually, we'll start with, we need a way to move the character. And Unity or mono behavior has a really helpful tool for this called transform. Transform with a lowercase t. You can tab to autocomplete .translate. And we'll look at the description for transform.translate. But transform.translate pretty much moves the transform in the direction and distance of translation. So it'll move the object. So we want our object, we'll start with, we want our object to move to the right. So we're going to go vector2.right. This provides a direction to the right, and we're going to multiply it by time.delta time. This way, the movement isn't super fast. Because this is called once per frame, time.delta time gives you the interval in seconds from the last frame to the current one. So this will make things a lot more reasonable because it'll move it only the amount of time that was in each frame instead of one whole unit every frame. And then we're going to also multiply it by a speed of, say, 2. And finally, don't forget your semicolon. Control S to save and go back to Unity. Unity will compile C# scripts. And we will play the game. And you'll notice that nothing different happened. And that's because you never added the script. We never added the script to the player object. So if you click on the player and go to the inspector, you always need to remember to add your script to the object that you want the script to affect. Otherwise, the script will just sit in your project tab and do nothing. So now that we've added the player movement script to the player, press play. And it should move slowly to the right. So we have a player that moves, which is perfect, but we want it to also take our input. We don't want it to just constantly move to the right, then there's no point in playing. So we're gonna go back to Visual Studio, and we're gonna want to get input from the player. This uses Unity's input class, but I'm going to offer a suggestion that we look it up because I'm going to be honest. Unity is a lot about looking up stuff. Unity documentation is one of the most helpful tools you will have in Unity, and I highly suggest that no matter what you are doing, look it up in either Unity documentation, Unity forums, and they'll help you with all of Unity's anything related to Unity. So we're now going to do search up Unity getting input, and we'll find it in the Unity documentation. And here we have a bunch of information about how to get input in Unity. So please, please, please do not try to do coding yourself or try to just figure it out. Use Unity documentation. It helps a lot. And here, as an example, in the update method, they have unity.get button down, fire one the code, and it'll do something. And this is exactly the code that we want to use. So we're going to go back to Visual Studio, and we're going to say if input, which is the Unity's input class, .get button down. We're actually going to go, because we want to do right and left arrow keys, we're going to do get key down. And if we look at the description of this, it'll return true during the frame that the user starts pressing down the key identified in the key code enum parameter. So we're going to put in that key code enum, which is key code dot right arrow. So if the player is pressing the right arrow key, we are going to move it to the right. And let's test that. Hit play, and hopefully when we press the right arrow key, our player will move to the right. Here you can see in our transform, our player is moving to the right, but only when we press the button, not when we're holding the right arrow. So in order to fix that, we'll go back to our code, and we'll see that get key down only returns true during the frame that the user starts pressing down the key, and not when it is being held down. So to fix that, we're going to delete the down, and we're just going to say input.getKey. And input.getKey returns true when the user holds down the key identified. So we want it to be called when the user is holding down the key. So that's the method that we want to use. So we're going to say else if. And also, if you're doing if statements or else statements or else if statements, if you type in if and then double tap tab, it'll autofill. Or if you say else if and press tab 2 times, it'll auto do like your if statement or for loop or something like that, which I find to be really helpful. If you want to use that, then go ahead. Let's say transform.translate. This time we're going to do vector2.left. Times time dot delta time times 2. And here we want to say input get key code left arrow. And so this will say if you're holding down the right arrow, move the player to the right, and if you're holding down the left arrow, move the player to the left. And just like that, once this is finished reloading, we should have a player who can move right and left. Now, I personally think that the player's moving a little bit too to say a 8. I'll try an 8. And then we'll test that. A lot of this transitioning into a lot of game design and game development requires a lot of play testing. So either play testing by you, or even better, when you're working on bigger games that you want a lot of feedback on, get other people, say friends or family, people who are open to giving you criticism to play test your game. That way you can make your game a lot better. So here we have our right and left movement. It feels pretty good, feels pretty clean. I'm happy with that. So now I'm going to duplicate this ground platform. We're going to make this ground platform a little bit smaller. Press R to bring up the scale to, bring W, we're going to move it to the left. And then we're going to go to the ground that we duplicated. We're going to call this ground 2. Press R to bring up the scale to, scale it down a little bit. Press W, move it, say, up here. And we're going to move the ground right underneath the player. So now we have a slightly harder level. And this is so we can implement jumping into our game. Obviously, right now, our player can't jump. So in order to do that, we're going to go back into our code. And we're going to check if input.get. Now, for jumping, we don't want our player to jump when the player is holding down the spacebar, because then it'll just jump off into infinity. So this time we are going to use input.get key down, and we're going to put in as our parameter keycode.space. So this is when the player is using hits the spacebar. Let's try another transform.translate. We're going to go transform.translate. We could do transform.translate vector2.up times time.delta time and times 8. But as you saw, when we use input.get key down and like just press the right arrow, it only moved a little bit to the right. So this is only going to move a little bit up. It's not what we want when we want a smooth jump. So what we're going to do instead is, instead of just moving the transform just like by hand, which is what this does, this manually changes the transform. We're going to add a force. We're going to add a force upwards to the player, which will simulate a jump. Like when you jump up, you have a force up. So in order to do that, again, if you don't know how to do this, again, I'm going to reiterate, use Unity documentation. But I will tell you that this is using the rigid body. We're going to need a reference to the rigid body. We're going to call the rigid body and call the method rigidbody.addForce. So we need a reference to the rigid body, as I said. And we're going to do this at the top of the class above the start method. And this is where we put our fields. Our fields are kind of variables in our script. So our variable is going to be referencing our rigid body 2D, call it RB2D. So we have a rigid body as a variable, but we don't reference the actual player rigid body. In order to do that, in the start method, say RB2D equals get component, the angle brackets rigid body 2D, and then our regular parentheses and semicolon. So this will get the component of the rigid body 2D that this script is attached to. and reference and put it in RB2D. So now we have a reference to our rigid body 2D, which is exactly what we wanted. We can call our RB2D dot add force. We need a vector2 dot force as a parameter, so we're going to say vector2 dot up multiplied by, say, 2. We'll start with 2, and if we feel like the player is not jumping as much, or if we want to jump more or jump less, we can change this to value. And let's play that. So still we can move right and left, and now when we jump, it doesn't seem to work that well. So we're going to need to mess with a few more values in a player. Maybe we try to boost this to, say, 50. See what happens when we add a force of 50. And hopefully now the player will jump a little bit higher when you press the spacebar. Here you can see the player does like a little hop if you look really closely. I don't think we're adding enough of force yet. So we're gonna go back, we're just gonna go crazy, just go 500. Make sure always when you change the script, by the way, I forgot to say this, Control S to save the script. If you don't save the script, Unity will not recognize any changes you've made to the script. And if you want, if you coded something and it doesn't seem to be working, make sure you save that code. Because it's possible, I've done this a lot, where I wrote the code, forgot to save it, and obviously Unity wasn't using the new code that I wrote. Go into play mode. Press spacebar, and now we have a really high jump. Which I think I like. But maybe we can mess with some values in the rigid body 2D and make it feel a little bit better. So first I'm gonna start with making the mass like 5. Jump. It's a little bit too heavy. Say start with 2. Still a little bit too heavy. I'm gonna go with like 1.25. And now we have a nice, I'd say a pretty solid jump. So now we have pretty much full, in our very basic 2D platformer, full player controls, where our player can move from one platform to the next. We can create as many platforms as we like, and yeah. So now that our game has our controls and we can create the ground, now we need a way to finish the game. We need some way that detects when the players reach the end of the level, so we can say, congratulations, you finished the game. In order to do that, we're gonna shift click both these grounds. We're gonna move it a little bit to the left. We're gonna move the player to the left. I'm gonna add one more ground. Click Control D to duplicate it. Call it ground 3. Make sure you're always organized. Click W and move it, say, up here. And I want to say that once you've reached the end of this ground on the right, the game will tell you that you've won, right? So in order to do that, we're going to need some sort of way that detects when the player has reached this point. And in order to do that, we need a collider that will, so that when the player collides with this object, some object over here, it'll notice that the player has reached the end. So now instead of creating a sprite, we're going to create an empty object with nothing and call it end or finish line. And we want to add a box collider to it. Also reset the transform. W to move it over here, and then R to scale it. W again, move it up, and then I think I want to make it a little bit thinner. Doesn't really matter, but so this is our collider. When it should be when our player, this object right here, collides with this collider, we want the game to end. But we don't want the player to just hit this invisible wall in the middle of our or at the end of our scene, because that'll look really odd for the player. So we're going to set it to is trigger. We're going to set that Boolean value to true. And what is trigger means is that instead of colliding with an object, it'll just like act as a trigger. It'll just call like something triggered this box collider, but it won't do any collision. So our player should be able to move through this, but the box collider will our player should be able to move the box collider while still noticing when our player has hit this box collider. So we want to add into our player movement script, we're going to add it's called on collision enter 2D. This is a script. This is a method made in Unity, part of mono behavior, which is called every single time this object, the player object, hits or collides with something. So when something enters the collision, it gives this parameter, the collision 2D collision. And we can go to our Unity documentation, look up on collision, enter 2D Unity. You can go to our documentation and you can read all about on collision, what the method means, how it works. And if you'd like to, go ahead. For our purposes, pretty much we want to say when a collision has happened, we're just gonna print or in Unity, instead of using print, we use debug.log, debug for debugging purposes, and log will just put it, you can type out something and it'll print it much like Java print. So be debug.log, you have one. So now when something's collided with this object, our player will print out you have won. This is just to make sure the on collision enter 2D works, but as you may have predicted, this will also be called when the player hits our ground object. If you go to our console, if you don't see the console window, by the way, you can go into Window, General, Console, and it'll show up. You can place it wherever you want to in your layout. But the console is really important. It's where you'll see all your errors and all of your debug.logs. And so when our player collides with any object now, it calls you have won. See now it's been called twice, 3 times. Obviously, this is not exactly what we want, but it's a good start. We know that the on collision enter has worked. So we need some way to differentiate between the ground and the finish line. And how the best way to do this in Unity is with tags. You can add a tag to any object. You can have a maximum of 32 tags. I can imagine because of the bit system, that's why. We're going to add a new tag, call it finish line. And then on a finish line, we're going to go to the tags and we're going to assign it to the finish line tag. Now, in our back to Visual Studio in our player movement code, we can say if our collision.game object, so the game object that is attached to the game object that we collided with, dot compare tag, And for compare tag, we can put in the tag that we said, which was finish line. If the collisions tag is the finish line, then and only then will we print out you have won. In an actual game, instead of just printing out you have won, you might want to go to a win scene. So you'll create a new scene, maybe put some art assets in, a text that says you won, or something like that. But for now, we're just going to leave it with it as a debug.log. And we're going to play it, and we're going to see if when we reach the finish line, you have won is called, and it is not. And that is because we set this to isTrigger, and in our method we use onCollisionEnter instead of, you can also use onTriggerEnter. And that will say when the object has another object has entered a trigger. But we can't use onTriggerEnter on the player. This is a little bit confusing by Unity, but I'll try to explain as best I can. And if you're confused, please ask questions. Pretty much, if we look at our player is not a trigger. So onTriggerEnter on the player will never be called, because nothing will enter a player trigger because the player is not a trigger. And so if our finish line is a trigger, we need to call onTriggerEnter on the finish line component. So we can either, our first solution would be to turn off isTrigger in the box collider. Then when we go to the right, there will be a collision. As you can see, I just jumped off of the, I just jumped on top of the collider, but this is pretty much an invisible wall now. But if you look at the console, you should be wait. Oh, and then of course we forgot to add our rigid body. I still forget to do this, but on a finish line, in order for physics to work, we need to add a rigid body 2D and a box collider 2D. We want to turn off gravity because we don't want our finish line to move. We want to freeze position and rotation. And then, even though we'll have a slightly invisible wall, when you hit the end of the the end of the world, or you hit the finish line, you have won will be called in your console. So you can see it's called 3 times now, 4 times. And now you've created a very basic game. You can always change up the platforms, make them smaller. Maybe you make this one very tiny, make it a little bit harder. You can add a lot of mass to the player, make it like 0.5. It'll jump a little bit less. You can move the finish line to say out there, but basically you've created a full game. But say we wanted to make the game a little bit longer, so we're going to add another. We're going to Control D. We're going to copy the ground. We're going to call this ground 4. We're going to move this using W. We're going to move it to the right and say now we want the finish line to move down there. So we have a little bit of a longer level, right? You'll see you can move. The camera does not follow the player. You'll see in the scene, our player has reached the end. We can move to the right and you have won will print, but you're not able to see it. The camera doesn't follow the player, which is not Exactly. We want the camera to be able to follow the player. And there are two solutions to this. One is a lot easier, but one looks a little bit better. I'm going to show you both just to show you a few concepts in Unity. The first is that we make the main camera a child of the player. Now, let me show you what that does. So if you take the main camera in the hierarchy and drag it onto the player, you'll see this little drop down. You'll see the main camera is a child of the player, which is what it's called in Unity. And now, if we go to our main camera transform, we will reset it. We'll remember to make the z-axis -10. And we'll play it. And now, no matter where the player goes or what the player does, the main camera completely follows the player. You saw when the player rotated, the main camera followed that rotation. And a child means that it literally follows around its parent, right? So now we can basically play the whole game, get to the end, reach the year of 1, and that's very much what we would like, but it kind of looks a little bit odd, right? When the player rotates a little bit, you don't really want the main camera to follow the rotation of the player. And also the fact that the player is always in the center of the screen looks a little bit odd. So we're going to make the main camera not in a child of the player. We're going to drag it out, and we're going to use a script. We're going to go to our scripts in the project tab, go to your scripts folder and create a new script called camera movement. And in this script, we're going to do all of the camera logic. First, we're going to make sure that we add the camera movement to the main camera. Oh, sorry, we need to let the script load. Wait a second. We're going to add the camera movement script to the camera. Double click on the camera movement script to open it in Visual Studio. And pretty much what we want this script to do is that there'll be a slight delay, but the camera should kind of follow the player, but also not rotate with the player, which is our two main goals. So first, in order to get the camera to follow the player, we need a reference to the player. So at the top in the fields, we're gonna say public game object and call it player. The public, what's it called? Like indicator here means a few things. This this variable can be accessed through other scripts. So say in this script, I wanted to have a reference to the player in the camera movement, which would be silly, but just as an example, you can reference this variable with other scripts, not just in this script, and also a very useful feature. The object or the variable becomes serialized, which means you can see it inside of the inspector. So if you click on the main camera, look at the inspector, you'll see the player. Right now it's not a game object, but we can drag in the player. And now we have a reference to the player just by dragging it in. We don't have to do much code for that. It's very simple. So that's a nice part of Unity. So now that we have a reference to the player, we want to follow it. Now we could do this in the update method, but Unity has a special other method called late update, which, if you look at the description, it is called every frame, but it is called after all of the update function is called. So this will give us that slight delay that first the player will move, then the camera move, which will make it feel a lot smoother. So we're going to delete the update method and the start method because we don't need those. And just in the late method, we want to change the camera transform. So the camera transform to be the player. But if we just do transform we can't do transform.translate because transform.translate will move it in a specific direction, but we don't know what direction the player is moving in, right? So we're going to use another method in Unity called transform.learn. Transform.learn is actually vector2.learn. So we're going to say our transform.position equals make sure you spell that right. Transform.position equals vector2.learn. And this vector2.lerp is a method inside of the vector2 class, which lerp stands for linear interpolation, which is a really fancy way of saying gradually moving. Again, we can look at the Unity documentation. We can search up vector2 lerp Unity. It'll pull up scripting API. I'll help you through the documentation. You can read all about how lerp works, what it means, how it works. If you'd like, read through that. Pretty much what we're going to say is lightly interpolates between vectors A and B by value of float t. So we want to go from our position, from the transform.position of the camera to our player transform.position. So we want to go from the position of this camera to the player position, and then we're going to call it a value of 1 for now, and we'll see what it does, and we can adjust that value as we see fit. Now let's go to our play. Hit play, let everything load. Because the main camera kind of got a little messed up, so we're gonna reset that, set it to -10 on position, and also we want our position goes to the player position. It doesn't change. It also changes the z value, which is this value over here, which means when the z value goes to 0, as we saw before, the camera goes blank, and we don't want that. So we want, after we change the position, we want the transform.position.z to equal -10 always. Oh wait, I already said transform.position equals new vector 3 transform.position.x transform.position.y and -10. So this is how you manually adjust the transform position of, if you're wondering what transform.position means, by the way, it's very clearly shown in Unity. It's the transform inspector and the position class. This is your transform.position.x, transform.position.y, transform.position.z is over here. Pretty much what we're saying is that our transform.position is a new vector 3 using the same x and y values, but we want to make sure that the z is always set at -10. F stands for float, and we're going to play this. And now you will see that the camera, while not being a child of the player, moves with the player, but it's not very gradual, right? It's very, you can see that it's very instant. And I think, and that's, you want to mess with this value, the t value in your vector2.lerp. Now we're going to change it to 0.2. So now instead of being our 0.2 f, we're going to float. Now our t value, instead of going right away, there'll be a slight delay. before our vector2 lurks from one position, from the camera position to the main camera position. And so you can see there's a slight delay. It's still not as much as I'd like. So we're going to change that to 0.1 and see what happens. Still, oh, I forgot, of course. We want to multiply by time dot delta time. When you're messing with the transforms, you always want to multiply the speed you're at by time dot delta time, because that will make it seem as though it is only moving like a reasonable amount per each frame. Because as I said, time dot delta time is the amount of seconds in each frame, and update is called every frame. And now we have, you can see our movement. Our camera kind of moves with the player, and now it's a little bit too slow because I multiplied it by time dot delta time. So we're going to change this to 0.5. Again, playtesting, messing with the values, seeing what we like, seeing what we don't like. And I think I kind of like that. And now we've reached the end. In our console, it says you've won, and we have our 2D platformer. And that's really all I had for this tutorial. Kind of an introduction, how to use Unity, how to get through. Well, at first it seems like a lot. It's really very manageable, and I hope I kind of conveyed that to you. And we created a very simple game that you can very easily manipulate how you'd like, changing the values in the script, changing like the speed your player can move at by changing player movement SCS. This value, which is the speed, or you can change the how fast, how high it jumps using this value. You can add more ground, you can move the finish line, really create however you'd like to design your 2D platform level. Does anybody have any questions?
All right, if nobody has any questions, I think we can end the session here. Thank you